So, in this session, we'll go through modularization techniques, what we use in ABAP. So, first, let's see what is modularization. Modularization means dividing a complex business logic into reusable blocks. So, dividing a complex business logic or a functionality into reusable blocks so that we can maintain the program or code easily. So for easy maintenance and for reusability, we use modularization techniques. So we create reusable module instead of creating everything in the program, instead of including everything in the program. What we do, we implement the logic as modularization units or blocks. So whenever we need a logic, specific logic, we use that logic in different application programs instead of writing or instead of developing it from beginning or instead of writing the same code, same functionality in different programs. That is redundant, right? So let's say you have some calculation in program A. So you have implemented that calculation logic in program A. Now maybe you need same logic in other program, right? So do we need to write the same code again in the other program? Right? That is redundant code, right? We are writing duplicate code again and again in different programs for the same logic. So instead of doing that, what we do, we create modularized modules or reusable blocks. So instead of writing it from beginning, we just call that unit or modular module in our program, right? So that we can avoid redundant code and we can easily maintain the logic part. For example, after some time, there is a change in that calculation part, right? For example, there is some tax calculation logic in our project. That is common, that logic we are using it in 10 programs, right? That logic we are using it in 10 programs, the tax calculation logic, right? Let's say we implemented this tax calculation logic like as an individual code, like a separate code in each program. We implemented the same code in different programs without using a modular unit or reusable unit. Let's say there is some change in the tax calculation logic after a few years. Then what we need to do? We need to go to all these 10 programs and change the logic, right? We don't use any reusable object or reusable module. We need to change that logic in all 10 programs, right? So instead of that, let's say we kept that logic inside a reusable unit, right? So now you call that unit in all 10 programs. Do we need to go to all 10 programs and change the logic if you are reusing that module? No, just go to that reusable module and change the logic in that module so that it will apply to all the 10 programs. Automatically, all the 10 programs will be updated with that logic, right? It is easy to maintain, right? If there are any changes to the logic, and we can reuse the existing logic. For example, user A already implemented one logic, one functionality in a specific program, right? And user B is working on something, he is developing a functionality where he needs to have same functionality which is already available in one application created by user A. Now user B, is he really need to create that logic from the beginning? No, right? He can just reuse the functionality which is already available in the project, right? So that functionality is already a proved functionality because that functionality is already implemented and all the testing scenarios are performed on that functionality, so it is working perfectly, right? So user B can just reuse it instead of creating it from beginning, right? But how can user B can access that functionality? The prerequisite is user A should have created that functionality in a reusable module, right? So that user B can call that module in his application. If user A doesn't create that logic as a reusable module, can the user B access that code in his application? No, he
No, sir.
cannot reuse. He needs to create it from beginning, right? So we can divide application program into reusable modules or units. So what is the advantage of dividing the program into reusable modules? To
Reusability.
reduce the yeah, that is one. Code redundancy, duplicate code. We can avoid duplicate code. Okay, and
To reduce as
easy
well as
to
also, sir.
yeah, easy to maintain. And what is the other advantage?
Faster.
Yeah, it will decrease development time, right? So it will decrease
Yes, sir.
development time. We can complete the applications quickly if there is any existing functionality available, right? These are the advantages of modularization techniques. Okay, so we have different types of modularization techniques available. First, let me show you like how this modularization will work. Let's say we have implemented some functionality in a program. Here, how we write the code. Let's say we implemented some functionality in program A. We have added all the statements in program A itself. We did not create any modularization unit. We created as of now like whatever the programs we created till now using all the select statements and all these things. Are we did we modularize them? No, we just implemented the code in the same program, right? So that we cannot reuse all that logic part in any other program, right? If you implement like this, let's say you created modules like this, module or unit or blocks, whatever we can call. So in this module one, we implemented this logic part one. Then the other module, some logic 3 we implemented in different module. Now what can we do? So in program B, so instead of creating that logic again, just call this module 1 here. If required, call module 2. So if you want to use logic part 1 and logic part 3 in program B. Similarly, you can call same module in other programs too, right? Here I need only logic part 3. I'll use only module 2. I'm not going to call module 1 since that is not required in the program C, right? Now whatever the functionality you implemented in this module 1 and module 2 will be called in program B or in program C when you are calling or when you are including those modules or reusable blocks in these programs. Okay. So we divide the program into reusable units, reusable blocks. Okay. How we are going to divide the program into reusable blocks, we'll see. Sorry. So we have different techniques available in modularization. First one, include programs. So include programs are one type of report programs. What is the transaction code to create report programs?
SC38.
Yeah, in SC38 we can create include programs. So what is difference between what is the type of the program we are creating as of now?
Executable
We are
program.
creating executable programs, right? How include programs are different from executable programs? So executable programs can execute independently. They can accept the input and return the output, right? So they can execute independently without any dependency. They can accept the input parameters and they can display the output. But what about include programs? Include programs we cannot execute independently. So include programs can work only with another executable program. When you add this include program to a executable program, then only whatever the logic available in include program will work. Otherwise, it cannot execute independently. So we can call this include programs in executable programs or in other include programs. You can add one include program to other include program. Okay. But when you add one include program to other include program, again you cannot execute them independently until unless you include or you added all these include programs to one executable program. You can only execute include programs through other executable programs. Okay, so cannot execute independently. We cannot execute independently. Can work only with executable programs. When you add this include programs to executable programs, then only whatever the logic in the include programs will execute. Okay. Can call in any program. We can call these include programs in any program. Okay, right? We have one more modularization technique. Subroutines. Subroutines are the other modularization technique available. But how it is different from include program? Subroutines are local to the same program. So subroutines are local to the same program. We cannot call the subroutine in another program. Okay, you cannot call the subroutine in another program. You can reuse whatever the code you implemented in the subroutine. You can reuse only within the same program. Right? Let's say in one application program, you need to repeat or you need to call a specific logic multiple times in the same program, right? Not in the separate program. Within the same program, you need to trigger a specific logic multiple times, right? Then you can keep that logic inside the subroutine and you can call the subroutine whenever you need to execute that specific logic in the program. But can we call the subroutine in other programs? No, you cannot call. If you create this subroutine in program B, you can use that subroutine only within program B. You cannot use the subroutine in program C. These are not global. What about include programs? We can call the include programs in other programs.
Okay.
So these are global objects, right? You can call globally. Globally means you can call in any other program. Okay, these are local, only within the same program. Okay, next, function modules. So function modules are also global objects. Function modules also global objects. So we can call function modules globally in any other program or in any other function module. You can call one function module in another function module also. That is also possible. Okay. You can create one function module in another function module also. So you can call the function modules in executable programs, include programs within the subroutines or within the other function modules. Okay, but how these function modules are different from include programs and subroutines? The very important difference is function modules can accept the input and return the output. So function modules can accept the input and return the output. But what about include programs? Cannot accept the inputs, cannot,
Return the output.
okay, no output. But when you add it to the include program, so that functionality will execute. But otherwise, independently, it cannot accept the input and it cannot return the output. What about subroutine?
It accepts the input and it
Yes,
accepts it returns the output.
can accept the input and return the output. But function module also can accept the input and return the output, right? But
Yes, sir.
what is the difference between subroutine and function module?
Subroutine
Subroutines,
is
yeah,
used in the
local to
same
the program.
program.
Subroutines we
Local.
can only use within the same program. We cannot reuse the subroutine in other program. But function module can be called globally in any program, in any include program, executable program, or in other function modules. Okay. So this is also a global object. You can call globally. What is the T code to create function modules? SC37. We have a separate transaction code to create the function modules, right? The transaction code is SC37. There we create the function module. So when we are working on the function module, we'll see in detail because there are few prerequisites to create the function module. Okay. So we'll see one by one. So which programming model it follows? Which programming model it follows?
Procedure.
Procedural programming model. Can you tell me any procedural programming languages? Procedural means depends on the functions, right? So can you tell me any few procedural programming languages?
C language,
C.
sir.
Yeah, C is a procedural oriented programming language. There we call functions, right? So can you tell me object oriented programming languages?
Java,
C
sir.
plus
C++,
C plus plus.
right?
Java.
Yeah, Java is also object oriented programming language. Here we use classes and methods. There are many important features of object oriented programming. We'll see when we are working on object oriented ABAP. So please make a note. ABAP, is it a procedural oriented programming or object oriented programming?
Uh, it uses both, sir. Or
Both. Okay. You can write code in procedural programming language using function modules or object oriented programming using class methods. So ABAP supports both procedural programming and object oriented programming. Okay. Is everyone clear?
Yes.
So T code is SC38 to create the include program. So what is the transaction code? SC38. Okay. In subroutines, where we can create subroutines. So you can create
Generally,
subroutine in a specific program.
Editor.
Okay. So we can call subroutines in function modules also, right? So we can call the subroutines within the one function module. We'll see how to define and call the subroutines in programs and function modules. Okay. Now fourth one, classes. Okay. So class methods can be called globally in any program, function module, or in another class method. You can call one method in another class method, right? So this follows which programming model?
object oriented.
Object oriented programming model. It follows object oriented programming model. So there are certain differences, sorry, yes, there are certain advantages of using object oriented programming than procedural programming in terms of performance, security, and maintenance of business logic, right? So we have certain advantages. So when we are working on this object oriented programming, we'll see all of them. So the T code to create class methods are SC24. SC24 is for global classes. We can also create classes locally in the same program. So whatever the classes we created locally within the same program, we can use only within the same program. We cannot reuse those class methods in other program. We have two types of classes: global classes, local classes, right? Global classes are like include programs or function modules. You can call it in any program, function module, or any other class method. But what about local classes? These are local to the same program. We cannot call them in the other program. Okay. For local classes, for local classes, we have a syntax. We can use that syntax to create the class methods in program itself. But for global classes, we need to create global classes separately. In which transaction code? SC24. SC24 is the transaction code for global classes. Okay. Now, out of all these modularization techniques, right, we have four different techniques, right? Four different modularization techniques, right? So, what is the preferable technique? Or do we use all these four in different scenarios? So, in these days, so in this in S4 HANA environment, like everyone is In every project, it is recommended to use class methods to implement your functionality. No one is allowing to write all the logic within the same program with thousands of lines of code one by line in the same program. So what we need to do, instead of writing all the logic in the same program line by line, what we need to do, we need to modularize the code. We need to modularize the code using class methods or include programs or function modules. But in these days, in most of the projects, so recommended to use class methods. Modularize your code into class methods and call the class methods in the program instead of writing all the statements in the same program. We are going to see each technique one by one. But what is the recommended method? Class methods, right? And we need to know how to call the function modules, even create the function modules. We'll see these modularization techniques one by one now. Is everyone clear on this? Any questions?
So in the classes, can you pass the values or
Yeah, yeah, sorry, yeah, good that you mentioned. So methods, inside the class we have methods, right? Methods can accept input and return the output. Okay, class methods can accept the input and return the output, just like function modules. Very similar, like if you know how to create a function module, like how to call a function module, class method is also similar in terms of these parameters, inputs and outputs. But the concept is different because function modules follows procedural programming, but class methods follows object oriented programming. But you feel it very similar, like if you know function modules, you can feel it very, like you can easily understand the class methods. Okay,
okay.
now let's create a program using this modularization techniques one by one. Let me create a new program. We can also have some existing programs, or one second, let me check if you have any suitable program. Can you see this? What is this CL demo output? So this is a
Class
class and this
class
is a
method?
method. CL demo output is a class and display is a method. Okay, this is a class method. And what is this? We are passing the input, right? And it is displaying the output. Okay, so let's quickly create one program and you will modularize that. First, we'll see how to use include programs. Let's create an executable program first. Save. I'm going to design some selection screen. Okay, frame is enough. Let's define some parameters. Let's take only one parameter for now. So I'm defining on select option. Select options. Provide the select option name for LV underscore matter. So this to define the select option. Let me also create one parameter. Type Bookers. Bookers, I think it's company code. Bookers is company code. So we'll take material number and company code as input. Initialization. Let me add date as well.
AUDAT, sir.
Okay, let me check the data element. I'm trying to get the data element. LV date. Type the data element, and I'll define one more select option. Okay, now let me add some default values logic, default inputs logic. So how can we implement default inputs? In which event we can pass the default inputs, default values for the parameters? What is the event? Initialization, right?
Visualization.
We can pass default values to the selection screen inputs using initialization event. Here, date hyphen low equal to, no, sorry, not date, AEDAT. Minus 60 days. Mm, sign include. What is the other parameter we have? What is the other field we have in select option? What is the other
Sir.
field we have? Option.
Option,
Option equal
sir.
to,
SIGN. Sir, SIGN, sir.
okay. See. Then append 88. I'm adding two different ranges. I'll add one more range between some range. Okay, I'm adding. So this is my default values. These are my default values. Now in that selection screen, if you want to add any validation, you can add. So we have a company code, right? Company code parameter, right? Let's validate this company code parameter. How to validate this? If
by using if condition.
not initial and if, how can we validate the value? Let's say user entered some
Select
company code. How can you know that the value is correct or not? We need to validate from the check table, right? So what is the check table for company code?
Uh, T001, sir.
T001. T001 is the check table. We need to verify the whatever the value entered by the user is available in T001 or not, right? If it is available in T001, that is a valid entry. Otherwise, invalid entry. Select single occurs from Bookers. Okay, Bookers is not there. Where Bookers equal to P underscore Bookers. Right? Is this key enough in the where condition? We are using select single, right? What is the recommendation to use select single? What are the recommendations to use select single? So we should pass all the primary key fields, right? In T001, what is the primary key field in T001? Go to the check table and check. We have only one primary key, that is Bookers. Company code is the primary key. So we are passing all the primary keys in where condition. Okay, that is mandatory to check. Even it won't display any error, but as per the programming guidelines, you should pass all the primary keys in the where condition when you are using a select single statement. Okay, then if sub rc equal to 0 and if when we need to raise this message, is it when sub rc equal to 0 or not equal to 0?
is not is not equal to 0, sir.
Yes, we need to raise the error when sub rc is not equal to 0. Not equal to 0 means what? The above
There is a
select statement
value.
is
The condition
failed.
fails, sir.
Not equal to 0 means there is no value or the select statement is failed to read this value whatever we are passing here. Okay, here we will write a join select if not what else. EBLP from EKPO from EKKO, inner join, EKPO. What
Sir,
next?
sir, in the EKKO, it
Hmm.
doesn't have mathematics.
Yeah, we doesn't have. We need to add these table names here, right? Let me add that first. What is the join condition? EKKO VLN equal to EKPO EBLN, and where, what is the condition? What are the inputs we have? Material number, date, created date, and company code. So material number is available in AKPO, created date and company code are available in EKKO. AEDAT in SO underscore AEDAT and EKKO hookers equal to, so company code is a parameter, that's why we are passing like this, and EKPO Matner in SO underscore Matner, right?
Sir, we should select EBLN from which table, no, sir?
Yeah. So that's why it is
EBLN
showing the
book.
error. If you check this, so
Sir,
the column
SO
name,
underscore mat, sir. What is
oh, okay. So it is saying the column name or association EBLN is ambiguous because EBLN is available in both EKKO and EKPO, right? So it doesn't know from which table it needs to select, right? So we have to specify that EBLN. Let's check the other fields now.
So
Hookers
Bookers
is
is also
also
there in
ambiguous.
table, no, sir. Definitely is also there, sir.
Let me leave it like this. I'm not adding table names here so that you can understand the difference when we need to use these table names versus just use all the field names without using this preceding table names. So we are missing into table from, yeah, into table at the rate data of LT underscore PO data. Check the syntax. No errors, right? Even though we are not using this preceding table names, right? Because Lifner, EBLP, Matner are not available in EKKO, right? So you can write like this. Even it's a join, it's not mandatory to use this table name, okay? But when that specific field is available in both tables, you have to mention the table name from which table you want to select that specific field. And if LT underscore PO data is not initial, and if inside that we'll call our CL demo output class method display just to display the output. Now let's see. So we have implemented the code, all the code within the same program. We did not modularize the code. So how can you modularize the code? First, let's see how can we modularize this using include programs. Okay. So what is the transaction code to create include program?
SC38.
SC38. Now provide a name. I'm using like this underscore top because I want to modularize. So I want to modularize this part first, the selection screen part, so that I can use the same selection screen in any other program if required, right? If I modularize this. Now create the program. For that I am using top underscore top because they are top declarations. What is the type of the program we need to select? Include program. Include program. Save it. So we need to select the include program. Now instead of keeping the code here in the main program in the executable program, I am going to copy and keep this in the include program. Let's activate the include program. Activate the include program. Now my include program is ready. Now use this include program. How can you call this include program in the main program? How can you call this? By using I'll remove this. So how can I call that? How can I reuse that include program in the main program using include statement? Include the program name. Include on the program name. So activate the main program. Now execute it. So your selection screen is here, right? Did I create this selection screen inputs in the main program?
No, sir.
No, I've
Yes,
maintained
sir.
the selection screen logic or selection screen statements in the separate program. That is another include program. So I'm calling that include program in the main program, right? Now, so you can call this include program in any other program. Let me create one more program. Program 2. So create executable program. Now let's assume we need a requirement of similar selection screen, same selection screen in other program too. Now what can we do? We can simply copy this program, include program, and call here using include this. Just check and activate. So you can see the same selection screen here, right? Similarly, how can we modularize this initialization logic? Create one more include program if required. How can we create include program? Go to SC38
Type,
and create it. There is another way of
type
creating it. There is another way of creating include program. Just type include and provide the program name. For example, Z module program underscore init, right? Did we create this program already?
no, sir.
No, right?
No, no.
Now, how can we create this? Just double click on this. Double click on the program name. Do you want to create the object? So create the object, yes.
Yes.
So it is automatically defined the type of the program as a include program, right? Save it. Keep your initialization logic here. Activate. Even you can add events. if you want initialization, right? Now I'll remove it from here. Since I've added initialization within the include program, this is not required, right? But to check which include program executing in which event, we'll keep this in the main program. Events will keep this in the main program. Otherwise, you can add these events in the include programs also, right? Now, this this initialization event, whatever the logic available in initialization event, can be reused in other executable program also. Simply go to the program, other program. If the same initialization logic is required, include and the program name. Okay, include and the program name. So activate the program.
So event is missing, sir.
All right, that's what I wonder. Initialization. So we have these default values here. Similarly, you can call in any other programs, any different programs if there with this, if you are going to use the same logic. Similarly, you can modularize selection screen validation and data selection. You can keep it in a separate include, or let me quickly create separate include programs. Include select validate, right? I think there is a limit for the program name. Let's try to keep within the limit. Create the include program. Yes. Go back. So we have an include program for validation. You can reuse the same include program in any other program whenever you need to validate this company code, right? Whenever you have a requirement to validate the company code, instead of creating it from beginning, what you can do? Simply use this include program, right? So that you don't need to worry about the select statement and error message. It will automatically trigger. For data selection, create one more include program. Keep this logic inside one include program. Whenever you need to have a similar data selection, similar join statement, instead of creating it from beginning or instead of writing a duplicate logic, you can call this include program. Since you see it's a very simple example, but in general we may need to write complex logic, right? So activate the main program. Now how many lines of code you can see? Very few lines of code, right? So there is another advantage of using modularizing the code for readability, better readability. So if another developer is looking at your program, right? So they should be able to understand it, right? If you write thousands of lines of code in the same program, it is very difficult to understand. So what functionality you are calling in which place, right? If you can modularize your code by using some class methods or include programs, it will provide better readability, right? It is easy to understand the programming logic. Okay. Now let's say there is a change in any of this data selection logic, right? So do we need to change this common data selection logic in all the programs wherever we are using same logic? No. If you are using include program, so you simply update that logic in the include program. It will reflect automatically in all the programs, whatever the programs they are using this include program, right? Automatically updated with this logic, right? Easy to maintain, right? Is everyone clear on creating include programs?
Yes, sir.
Yes.
So include programs cannot be executed independently. This can execute only with the other executable program when we add this to the executable program. Okay, it cannot accept any inputs and return the outputs, right? But if you like where we kept the selection screen in one include program, right? When we execute, it is displaying the inputs, right?
Yes,
Are
sir.
they executing from include program? No, right? It is just reusing these statements and executing from executable program. When you add this include programs to executable program, whatever the logic you implemented inside this will be part of executable program. Okay.
Sir,
Yes.
sir, in debugging, will it show all the logic, sir?
Yeah.
Or
Yeah. Let me find some data to execute. Maybe company code EKKO. I see more entries with this M350. Let me use that. Let me keep a breakpoint. I'll keep one breakpoint in initialization. Go to the include program. Keep one breakpoint here and keep one breakpoint in data selection. Execute the program. First, it is executing initialization include program. Where are we now? In this include program. This is the main program and this is the include program. Now we are in the include program. F5 to execute line by line. Let's say I don't want to debug further. I don't want to debug further. I want to jump to the main program. Which key we need to use? Now we are in the include program, right? Now the controller is in the include program. Now if you want to jump to the main program from the include program, which key we need to press? F5, F6 or F7 or F8? F7. F7. If you press F7, you can
your voice is
Breaking, sir.
breaking, sir.
sorry. Sorry, what? Sorry, looks like I pressed some wrong key.
So your voice is breaking, sir.
Hello? Is it clear now?
Yes, sir, it's audible.
Yeah. So now we are in other sorry, looks like we did not enter the company code. It will fail. What is the company code? M350, right? So execute. Now we are in which we are in data selection include program. F5, jump to the main program. So we have some records, no records. Looks like we don't have proper data for the selected inputs. Let me go back. Let me go back. I don't think we can go back to the other event. Yeah, we can go. We can't jump to the other event. Okay. So we can jump to the code within the same event. Looks like there is no data within this combination of date and company code. Savarsi 4. Let me remove this date range so that it will select whatever the records available on that company code. So what is the difference between select option and parameter? If you don't pass any value in the select option, it will select all the values, right?
It will fail
It will check for
Yes,
all
sir.
the materials, right?
in the
But what about parameter? It is equal to, it will always check for the exact value. Okay, so execute. So we got some data, right?
Yes, sir.
So this is how we can modularize a code using include programs, right? Let's see the other options in the next class, like subroutines, function modules, and class methods.
Sir, sir.